This is the avocado oil extraction experiment that Jake and Sarah and I worked on. So the outline of this presentation, go to the background, purpose of biofuels, and what they're about, objectives for the whole experiment, the process that we used and why we changed things and added things, the variables that we did change, the results of ours, and then previous colleagues' results compared to our results, and then a conclusion of different things in the procedure that should be used, limitations, and then followed up with the EHS and PV. Alright, so biofuels could really be a whole another 3 presentations, so this is very basic. Biofuel, like the reason for it is it's renewable and it reduces harmful emissions. Combustion in cars especially emits carbon monoxide and nitrous oxide. Adding in renewable fuels, biofuels, reduces that. So in ethanol, when this is added in, which is regulated by the government, I think they can add up to 15% to our gas, and all the gas we buy has ethanol in it. And it increases the octane rating, which makes it reduce the emissions of carbon monoxide. And biodiesel is the same thing as the same concept as gasoline, but a much bigger chains of hydrocarbons. And so the engines have to be designed to break down the larger hydrocarbons. So what biodiesel can be used for is it's mixed with a small amount of methanol. And it is used as an additive in diesel, or it can actually be ran by itself. So the objectives of this experiment was to develop an extraction procedure based on previous colleagues' results and their procedures, compare them to the colleagues' results, and then hypothesize and minimize the variation, the discrepancies in the results, and then achieve the standard operating procedure. So a little background on avocado. The skin contains about 7% of the oil content. The seed contains about 2%, and the flesh contains anywhere between 8 and 30% of the oil. Hexane is used as a solvent because it's non-polar. Why it's so good is its low boiling point and its non-polar ability or composition of it makes it very soluble in oils and fats. And you can remember like the like dissolves like when we're trying to think about this. Then also another great property of hexane is that doesn't blend with water. So when you dehydrate it, you don't have to worry about pulling the water, or when you're blending it, you don't have to worry about pulling the water out near as much. So the variations that we noticed from previous colleagues' procedures was the blending, separation, hexane recovery, and oil density. The blending, because the better blending, the more you break down the cell walls, the hexane can extract more oil out of it. And then the separation part is once this mixture has been blended, then you have to separate the solids from the liquid, and that process usually takes up a little bit of what you've made. So you lose about 50% to 30 to 50% of what you started off with just by separating it. And then hexane recovery is one of the goals in this lab. The oil density has also been a problem in previous procedures and results. You'll see, we'll talk about that a little more later. So what we got to use is we set up the homogenizer, which really helped in that blending part of procedure that other people didn't have. This is a great improvement to this whole process experiment. Homogenizer homogenizes mixtures, and what it means is having the same composition, structure, or character throughout. basically what it does is it's destroying these cell walls of the avocado and allowing the hexane to come in and bind with the oil. So this is the process we used. We started off with avocados, sliced them in half and de-seeded them. One of the variations we changed was dehydrating. We tried some without dehydrating. We tried some dehydrating in their skin, dehydrating without their skin, and at different times, or different dehydration times in the oven. Once it's dehydrated, you have the flesh and the hexane. The hexane is added to the flesh on a mass basis of 3 to 1. So if you have 10 grams of flesh, then you're going to add 30 grams of hexane. So what we do with this combination is put it in a beaker and homogenize it, and you can tell after about 10-ish minutes, the solids are really small particles and they're down at the bottom, and it completely separates the solid from the liquid content. What we noticed with the non-dehydrated avocados is that water would actually blend with it too. The homogenizer was that good to blend the whole thing together, and then it was inseparable, basically. So once we've homogenized it and blended it, we separate it. And this is one of the problems with a lot of people's procedures is there's seed trays, coffee filters, sometimes just like decanting it out. Most of these, in most of these procedures, we lost a lot of this liquid that we're trying to contain, the hexane oil mixture. So what we did to counteract that was we tried different methods. So we tried a Buchner filter, or Buchner funnel with filter paper, without filter paper. We also tried just decanting the liquid out and leaving the solid. And we also tried pressing in the Buchner funnel down on the solids to try to wring out what was left of the liquid. So once you separated it, then you have your pulp that you discard, and then this liquid, which is hexane oil mixture. And then it goes into the rotovat, which basically you pull this down, it comes into this bowl, into water, which heats it up. You pull it to about 72 degrees, since hexane evaporates off about 67, and then gets rid of the hexane and condenses it back into that bowl, and then what you're left with after that process is your oil and hexane separated. Like I just talked about, the changing variables, we changed the dehydration times, whether it was in its skin or not in its skin, and we tried a round or two without dehydrating it. In the separation method, the Buchner filter with filter paper, without filter paper, cold pressing it, and just decanting it. We also tried different variations of the time of the rotary evaporation, and different degrees and spinning, or rotation of the bowl. So ideally, the recovered hexane would be 100%, which is impossible almost to achieve, the ideal. And then its density would be 0.658 grams per centimeter cubed. And then the oil that's recovered, avocados in the flesh contain 8 to 30%, so anywhere in that range would be acceptable. And then the density